In this lesson, we're going to define trigonometric functions off of this unit circle. So if you graph the equation x squared plus y squared is equal to 1, you get a circle of radius 1 centered at the origin. And what we're going to do is relate points that fall on the circle to angles. So let's actually do that in example 1. To start with, let's find an angle that relates to the point 0, 1. And we're going to do this in a very specific way. All right, so the point 0, 1 on this circle has 0 for an x value and 1 for a y value. So that's the point right here. Let me label it. That's the point 0, 1. The way we're going to create an angle is by drawing a line down to the point 0, 0, and then drawing a line on the positive x-axis. And then this is going to be the angle here that we're talking about. It's the angle that moves the point from here to here. Now, the angle that relates to this point is going to be 90 degrees. And if you want to write that in radians, that is pi over 2. You can do this for any point that falls on the circle, but I just started by using this one here. Okay, well, what about the point 1, 0? Okay, so the point 1, 0 is 1 for x and 0 for y. That's located right here. So I'm going to label it. So there's 1, 0. Now, if you try to draw an angle this way, so I draw a line that goes back to the point 0, 0, and then another line on the positive x-axis, and it looks like, well, we didn't go up or down, so this didn't rotate whatsoever. Therefore, an angle that corresponds to that is 0 degrees, or if you'd like, 0 radians. Same thing. Okay, we'll do one more. Well, what about the point -1 for x and 0 for y, which is sitting right here? So I'll label that point. So this is the point -1, 0. I go back to 0, 0, and then create an angle with the positive x-axis. Okay, this time, the angle is the one that moved the point over here. And I know an angle that I can use is going to be 180 degrees. Or if you're working in radians, you could say that's pi radians. So I did it for these three, but you could use any spot that you'd like. Any point you choose can relate back to an angle, and any angle can also relate to a point. So more abstractly, if I pick a point here and call it x, y, it's very easy to relate it back to an angle. And that angle is going to be represented by this spot here, which I'll label as theta. Okay, we can now define our first trig functions. If you have an angle, that angle connects to a point, the point has an x and a y coordinate, we call the x coordinate cosine, so x is going to be cosine, and the y coordinate we call sine. You want to have some way to reference the angle that you're working with, so this is typically done by saying, okay, well, x we'll write cos for cosine and then put the angle next to it, theta. Likewise for y, you'll abbreviate it sin and put the corresponding angle next to it just like this. So if we want to just like check a couple of the points that we used here, let's focus on this very first one that I drew on the unit circle. Okay, this was the point 0, 1, so that's 0 for x and 1 for y, and the corresponding angle was 90 degrees. So that is, what is cosine of 90 degrees? Cosine of 90 degrees would be the x-coordinate of this point, which is 0. What is sine of 90 degrees? That is going to be the y-coordinate of this point, which is 1. So that's the definition of sine and cosine. The idea is you can draw an angle. That angle gives you a point. The x-coordinate is cosine, and the y-coordinate is sine. There are three important angles when dealing with trig functions. Those angles are 30, 45, and 60 degrees. And their corresponding radian measurements are next to them as well. These are going to be referred to as reference angles. So to start with, I'm going to label 30 degrees, or pi over 6, on this unit circle. So let's see, that's maybe, I don't know, it's not going to be perfect, but something like right about there. So here we have an angle with the positive x-axis, and this point has coordinates of the square root of 3 over 2, comma, 1/2. All right, so what this means is if you evaluate cosine of 30 degrees or cosine of pi over 6, they're equal, the answer is going to be the x-coordinate, which is the square root of 3 over 2. So that is an exact value. Likewise, sine of 30 degrees, or sine of pi over 6, is going to be the y-coordinate, which is 1/2. Moving on to 45 degrees, or pi over 4. So that's roughly here. Okay, so this point has coordinates the square root of 2 over 2, comma, the square root of 2 over 2. And what this means is that cosine of 45 degrees is root 2 over 2, and that's actually equal to sine of 45 degrees. It's also the square root of 2 over 2. The last angle, which is 60 degrees, so roughly here. Okay, the coordinates of this point are 1/2 for the x-coordinate and root 3 over 2 for the y-coordinate. So these two flipped around up here. What that means is cosine of 60 degrees is equal to 1/2, and sine of 60 degrees is equal to root 3 over 2. It is important to have these values memorized, and we will apply them in a couple of questions. In example 2, I want to evaluate sine of 5 pi over 6 and cosine of 5 pi over 6. We're going to use a reference angle to do this, as well as some symmetry on this unit circle. So to start with, we have to know a reference angle that we would like to use. And that reference angle is going to be pi over 6, or if you'd like, 30 degrees. And the reason for this is I'm seeing this pi over 6, and there's a 5 here, but I'm guessing pi over 6 somehow is connected to this thing here. Step 1 is, okay, where is this angle located, the reference angle? I know 30 degrees is roughly something like, something like that. It's not perfect, but this spot right here. So this angle is 30 degrees, or pi over 6. I know the x-coordinate of this point is going to be the square root of 3 over 2, and the y-coordinate is 1/2. So we have to know those two things first. And also, I know that cosine of pi over 6 is the x-coordinate of this point. That's by definition of cosine, and so the answer is, well, this is root 3 over 2. Likewise, sine of pi over 6 is going to be the y-coordinate, and so that is 1/2. So we have to know all of this ahead of time before we can figure out what these two things are equal to. All right, so it didn't ask us about sine of pi over 6, but it asked us about sine of 5 pi over 6. So the question is, can we locate 5 pi over 6 on the unit circle, wherever it is, and then can we somehow use symmetry of this circle to figure out what this thing is equal to? So that's like step 2. Where is 5 pi over 6? All right, here's how I like to figure this out. I can label some radians. So I know this is 0 radians. This is pi over 2. This is pi. This is 3 pi over 2. And then we're back to 0 or 2 pi. Now, over here we have pi. And that's actually going to be very close to 5 pi over 6. So here's why. Pi is the same thing as 6 pi over 6. In fact, if you cancel those 6's, it takes you back to pi. So pi and 6 pi over 6 are at the same spot. If you go backwards pi over 6, you will be at 5 pi over 6. So what we're going to do is travel backwards by pi over 6. What happens is you're saying, well, I'm at pi, I'm going backwards pi over 6, and that's equal to 5 pi over 6. So I do a trick like this to find the location of 5 pi over 6. So it is this angle here. All right, so if this is pi over 6, the way symmetry works on the unit circle is that 5 pi over 6 is directly opposite, a mirror image over this axis. So that's right here. It's on the same level as this point here. If you want to know sine of 5 pi over 6 and cosine of 5 pi over 6, you just need to know what the x and y coordinates of this point are equal to. Well, I know that the y coordinates are going to be the same because this point just gets reflected over here, but the x coordinate is going to be the negative of it. So if this point gets reflected over here, it has the same y value, but it has a negative x value. Let's put that over here. The coordinates of this point are negative root 3 over 2, comma, positive 1/2. This became negative. This stayed the same. We can now answer what sine of 5 pi over 6 is equal to. Sine of 5 pi over 6 is going to be the y coordinate of this point. So the answer would be, it's 1/2. Cosine of 5 pi over 6, well, it's the x coordinate of this point, which is the negative of this one because the x value had to move over here. So this is going to be negative root 3 over 2. This is how you can use symmetry and reference angles on the unit circle to take some previous knowledge to figure out values on trig functions for different angles. In example 3, I again want to use the unit circle to evaluate these trig functions for angles of 4 pi over 3. So to do that, I want to put a reference angle on this unit circle. Since I see a pi over 3, I'm guessing that the reference angle is pi over 3. Also 60 degrees, same thing. So where is that? That's about, draw that in here. I think that's something like this. So this is my angle of 60 degrees, or pi over 3 radians. So we already know that the coordinates of this point are, okay, the x value is equal to 1/2, and the y value is root 3 over 2. This is helpful because, well, I don't know sine of 4 pi over 3, but sine of pi over 3 must be the the y coordinate of this point, which is root 3 over 2. And cosine of pi over 3 is the x coordinate, which is 1/2. I can somehow use these values and symmetry of the unit circle to figure out what these two things are equal to. All right, the next step is going to be, well, where is 4 pi over 3? All right, let's see. Maybe again, writing down, I know this is 0 radians. This is pi over 2 radians. That's pi radians. And this is 3 pi over 2 radians. And then we're back to 2 pi. I think I'm focusing on pi again. Pi is the same thing as 3 pi over 3. That must be true. If you cancel the 3's, it would take you back to pi. So 3 pi over 3 and pi are the same angle. All right, if you go pi over 3 more, if you go another 60 degrees, you'll be at 4 pi over 3. So the reason for that is, if this spot here is 3 pi over 3, and you go another pi over 3, so that's another pi over 3, you will end up here, which is 4 pi over 3. So I'm just doing a little trick to figure out what this is equal to. I know pi is equal to 3 pi over 3, and therefore I'm adding pi over 3 more to it to give me 4 pi over 3. So I found my angle. It should somehow be symmetrically related back to this point here. And I can see that it's over this line here. So it's down like this. So how do I move this point, the x and the y coordinate, to get down to this point here? There are going to be two differences. One, okay, first, the x coordinate has to become the negative. So this is going to flip over here. So this positive 1/2 will become negative 1/2. The second thing that happens is the y value is going to become negative as well. I now know the coordinates of this point. So this point, I'm running out of space. I'll put it over here. The coordinates are going to be negative 1/2, comma, negative root 3 over 2. Now the reason for that was this point first reflected here, which made the x coordinate negative. The y value reflected down here, so it became negative as well. Since those two were positive, they are now both negative. That means I know what sine of 4 pi over 3 is equal to. It's the y coordinate of this point, which is negative root 3 over 2. I also know cosine of 4 pi over 3. That is going to be the x coordinate of this point, which is negative 1/2. So the takeaway between examples 2 and 3 is, if you know the values for your reference angle, the answer will be closely related. It'll either be the positive or the negative of the ones that you start with here. There are 4 other trig functions that are based off of sine and cosine, and I'd like to list those out now. So we define sine, abbreviated SIN, and cosine, abbreviated COS. The other 4 trig functions are the following. Tangent, abbreviated TAN, it's the ratio of sine and cosine. So if you know sine and you know cosine, the definition of tangent is you divide these two things. Sine's in the numerator and cosine is in the denominator. And we call this tangent. The 3 other main trig functions are the reciprocals of these 3 functions. So another one is what is referred to as cosecant of theta, and this is defined as the reciprocal of sine. So if you know the value of sine, you can flip it and put it into the denominator of a fraction, and we call that cosecant. Likewise, for cosine, it has a reciprocal, and that's referred to as secant of theta. And the definition is 1 over cosine of theta. There is a reciprocal for tangent as well. That is called cotangent of theta. And this will be defined as cosine of theta divided by sine of theta. So here you're just reversing the order in which you divide the 2 trig functions. These are the 6 main trig functions that we'll be using the rest of the semester. Now that we have defined 6 trig functions, what I'd like to do is plot this point on the unit circle and draw an angle that relates to it, and then evaluate the 6 trig functions for that angle. So I guess I'm going to start by plotting this point. That's 1/2 for x and negative root 3 over 2 for y. So we're talking about this point right here. So let's see, I'll draw this line with the positive x-axis as well. So here's my angle theta, and that's corresponding to the point of 1/2 for x and negative root 3 over 2 for y. For starters, can we figure out sine? And can we figure out cosine of this angle? That should be easy based on the definition of sine and cosine. We define sine as the y value of this point, So that would be negative root 3 over 2, and that's my answer. Cosine is going to be the x-coordinate, and so that is equal to 1/2. So of the 6, we figured out 2 of them. All right, let's add another one onto here. What is tangent? Tangent of this angle is going to be the ratio of sine and cosine. So that's equal to negative root 3 over 2 divided by 1/2. Obviously, that's not a simplified answer, but let's go ahead and simplify it. One way you can do this is by multiplying the top and bottom by 2. Multiplying by 2 over 2 is the same thing as multiplying by 1, so it doesn't change the value of this fraction. But 1/2 times 2 is 1. Let's see. We'll get 1. And then this 2 multiplied to this fraction will cancel with this 2 in the denominator, and that leaves me with a negative root 3. And there we go. I know what tangent is. Tangent of theta is equal to negative root 3. So we're halfway there. I know sine, I know cosine, and I know tangent. That leaves me with cosecant, secant, and cotangent. And the good news is those are the reciprocals of these 3 things. I'll put those on the next slide and let's see what we get. Okay, so sine was equal to negative root 3 over 2. Cosecant of theta is defined as the reciprocal of this trig function. And if it's already a fraction, I know I can just flip the numerator and the denominator. That would be 2 over root 3. And that's pretty good. I mean, that is an answer. Unfortunately, the answers in my lab have to be entered with a rationalized denominator, but there's a very nice trick to make this work. What we can do is multiply the top and bottom by root 3 over root 3. The reason this is not considered simplified is because this denominator is an irrational number. If you want to make it rational, you can multiply this number by itself. Root 3 times root 3 is equal to 3. The denominator will no longer be irrational. You'll have an irrational number in the numerator, but that'll be okay. So that is cosecant of theta is equal to negative 2 times root 3, all divided by 3. And this will be considered our simplified answer. All right, likewise, we figured out cosine was equal to positive 1/2. Now, secant is equal to the reciprocal of this thing, which would be 2 over 1. But, I mean, really, I think we'll just write that as 2. We do not need to rationalize any denominator. That is our answer. The last one was for tangent. Tangent was, we got negative root 3, or if you want, negative root 3 over 1. Cotangent is the reciprocal of this, which is negative 1 over square root of 3. Now, again, we have an irrational number in the denominator, but we can multiply the top and bottom by the square root of 3 again. When we do that, we get that cotangent is equal to, we get negative root 3 on the top, the denominator equals positive 3, and this is the answer.